So this is the first part of lesson unit 2D. Not a lot of calculator use, more conceptual, just naming some things here. This is the homework from the last lesson. Okay, influential point. So y'all have been asking about this actually. Every time we see a point that's kind of different than the rest of the group, what do you call it? Well, we've kind of been shy about that. We haven't told you, but we're going to talk about it now. So this is what today's lesson is about. Points with high leverage have much larger or smaller x values than other points in it. So those are called high leverage points. So the x value is way different from the other points. We'll see examples in just a minute of where your x values end at 10 and you've got a point at 15 there where it's just way bigger. So that's going to be a high leverage point. It's going to have a huge influence on the regression. What's an outlier? So in this setting, it didn't say this, but the x value usually is pretty within the pattern. So it's kind of a, not necessarily an unusual x value to the right or left. It's more about it just doesn't fit the pattern. Maybe it's way above the data or way below the data. This is typically what an outlier might look like. Again, we'll show pictures of this in a minute. An influential point is one that if you remove it, it's going to change the slope or the y-intercept or the correlation or the coefficient. I mean, all points might change that somewhat, but influential means it's going to change some of those things quite drastically. How do unusual points affect a scatter plot? Oh man, so much. Okay, so case one, no unusual points. So this is just 8 points. They're kind of positive, weak or moderately weak there. Relationship, R is 0.41. So, positive, weak, moderately weak relationship. Okay, so we're going to add 1 point to these 8 points. So all those points are staying the same though. So those points are not changing. For case two, let's see what happens. We added a point way out there to the right. You can see the x value is far removed from all the other x values, which are around, 3 to 6 or something. So that x value is 35. So what is that called when it's way different from the other points? So by the way, so before we talk about what the point is called, the equation did change. We put that point right on the regression line. So it's interesting. Didn't change the equation. R is way stronger. Well, that's really interesting. It went from being kind of weak to pretty strong, right? R squared changed quite a bit, so it got a lot bigger. So we can, again, R squared is the coefficient of determination. 89% of the variation in Y can be explained by X and the linear regression there. And then the standard deviation changed a little bit, not a ton there, but a little bit. So that is called a high leverage point. And you can see, really, of all those values, it affected R the most. It went from weak to strong. So when you put a point way out there, it actually makes the strength of the correlation quite a bit more. So that's really interesting. I really like choosing a point right on the regression line there. So this one, they did not choose a point on the regression line. It was way below the regression line. Same x value, so far removed there. The equation, oh my goodness, the slope went from positive to negative. The y-intercept was 3 point something, now it's 5 point something, so that changed quite a bit. It was a positive, R was weak and positive, right, R 0.41, now it's negative and weak. It's interesting it's still weak there, but yeah, that makes sense. And then R squared changed a little bit and so forth. So what is that point called? So this is also a high leverage point. The x value is so much different, so we call that a high leverage point. Case 4, I guess, actually. So what changed? So the slope was 0.65, slope still 0.65. The y-intercept, interestingly, the slope did not change, but the y-intercept did. Now, part of that might be because the x value is not much different than it was before. The x value of those points are pretty normal, right, for that outlier point up there. But it's so far higher, it brought everything up. That's really the main change. I guess R went from 0.41 to 0.11, so it made it a lot weaker. Yeah, so it did change that. Standard deviation is a lot bigger. There's more spread there for the residuals. Since the point has a very large residual, this point could be considered an outlier. So again, the X value is not that much different, but it just didn't fit the pattern at all. Okay, outliers and high leverage points are often influential for sure. Those are all influential points for sure. Any of those points are. Just perform regression and see what their results are with or without them. So I really like what they did on that one. So this one, a scatter plot of forest area and number of trees and each state in the United States, excluding Alaska and Hawaii, along the least squared regression line. Wow, so I see some interesting points there, Texas and Maine. Describe how the point Maine affects the least square regression line. So Maine probably didn't change the slope much, but the y-intercept would be higher because Maine is part of the graph. R is weaker, right, because it's way outside there. R squared is going to be a larger value as well. Standard deviation of residuals definitely larger because of Maine, right, because without it, it would be much stronger. Is this point an outlier or a high leverage point? I would say an outlier, right? It's doesn't fit the pattern, and the X value is not much different than the other X values, so I would say that. Describe how the point Maine affects that. Is this point an outlier or a high leverage point? So we already talked about this. So it increases the y-intercept. Right, so if the large residual is an outlier, making the value of R and R squared 0, increasing the standard deviation. Okay. So Texas, what is that one called? So so it's definitely an influential point, but it's the X value is so far out there. So that would be a high leverage point, right? How does it affect the least square regression line? Looks like, it might affect the slope and y-intercept a little bit. It's a little bit below, so maybe the slope has changed a little for sure. Maybe the y-intercept a little bit, not a ton of change there. R might be stronger because it's not far outside the pattern. R squared might be stronger, and standard deviation of the residuals might be smaller because it's not that far away from the thing. It's not an outlier because it's in the pattern. Doesn't have a large residual. It is a high leverage point. It is pulling line towards itself, making the slope of the line closer to 0. Or smaller, in other words, and the y-intercept would get greater because of that. Is it a high leverage point? Yes. Since this point is in the pattern, makes the values of R and R squared closer to 1. So it makes R and R squared a little stronger because it's a high leverage point, so it has a huge effect, and it doesn't have a large residual, so it would make it stronger. Okay, compute property taxes in Pennsylvania. The state assigns a value to each house. We've talked about this in living space. So describe the point representing house A. Ooh, so house A affects the least squared regression pattern. So what would A do to the least squared regression line? So it's not going to have a huge effect on the actual equation. Maybe I would bring the slope a little bit higher, so the y-intercept will get a little lower because it's below the line on that side. R would probably get stronger. R squared would get stronger because it has a very small residual there. Standard deviation residual would get smaller, which because the residual is so small there for that point. And I don't think it's as a below. Let's see. So as a below average living space is below. It's pulling the line towards itself, makes the slope greater, the y-intercept closer to 0. It's not a high leverage point, right? It's just a regular point in there. Okay. Describe house B. So what does that have an effect? So it looks like an outlier to me because the X value is not much different, but it's way outside the pattern. So that would probably have not much of an effect on the slope, but it probably would raise the y-intercept, is my guess, for the least squared regression line. R is going to be much smaller, not as strong, because that point has a huge, residual there. R squared is not as big. Standard deviation residual is not as big, or would be larger, right? Because it has a large residual. So it's going to make it in general larger. And that's what they said. You can read that. That's your lesson for today.